The Choices and Challenges Forum series was developed at Virginia Tech to explore the ethical and social dimensions of science and technology. The following presentation, taken from one of the forums in the Choices and Challenges series, is made possible by a grant from the Center for Excellence in Undergraduate Teaching. Additional support has been provided by Video Broadcast Services and the Center for Interdisciplinary Studies at Virginia Tech.
As a leadoff speaker, I've been asked to frame the discussion of pesticides, their nature and use. Now, as you well imagine, this is a large and complex subject. Could take quite a while to do, but in the interest of time, I've chosen to use several slides which will summarize quite briefly some of the major points that I wish to cover. For most American baby boomers and younger, the vision of healthy, attractive, inexpensive food is taken for granted. But we only need to travel abroad to other countries or watch television at night to quickly realize that American production of food, feed, and fiber is quite unique. This country has changed in recent years from that chiefly of an agrarian society to one in which about 2% or less of the population produce the food required by the other 98%, and in addition we are the leading exporter of food to other parts of the world. Today we spend about 11% of our income on food. You'll note that the slide that's shown here on the television indicates a higher number. Well, in the 9 years since that study was done, these numbers have continued to change, and as you can see, only 11% today is spent on food. Pesticides, also called agricultural chemicals, crop protection chemicals, have contributed much to this standard of living by improving the quality and the quantity of food we eat, reducing the cost of production and thus the food cost to the consumer, protection of perishable fruits, vegetables, and other widely used commodities that we enjoy year-round, and finally the protection of humans, livestock, and pets from insect-borne diseases. Fungicides are an important type of crop protection chemicals. They prevent or cure many of the plant diseases which can destroy plants and seeds during their production or storage. Despite enough varieties of fungi to cause more than 1,500 different kinds of diseases, there are actually only a few effective fungicides on the market. The extent to which these fungicides are needed to protect crops was highlighted last week by the Urbanchuk study of fungicide economic value conducted by GRC Economics. This new study clearly demonstrated that our lifestyles and health would be adversely affected if fungicides were eliminated in the United States, and our food, feed, fiber, floral, and nursery crops would be severely damaged by the diseases that fungicides prevent or cure. U.S. supplies of fruit and vegetables would drop between 24 and 80% depending upon the specific crop. Some crops such as apples, peanuts, bananas would be severely affected. Many produce and fruit crops would be almost unavailable here. Quality of the crops would decline, and year-round availability would be a thing of the past. Of course, per capita consumption of these crops would decline significantly as their quality declined and their prices rose sharply. Decreased consumption of fresh fruit and vegetables could also have an adverse impact on our health. Finally, the study estimates that approximately 250,000 jobs associated with the growing, processing, and selling of crops would be lost if fungicides were banned in the United States. As important as disease control is in the United States, insect control is even more important for many crops. There are more than 1 million insect species. They can quickly destroy an entire crop, farms, crop supply, or nation's food supply. The economic value of insecticides is quite significant. Some crops, such as cotton, can't be economically grown without them. Other crops, such as corn, soybeans, and rice, also rely heavily upon insecticides for control of specific soil and leaf insects. Herbicides are pesticides that control weeds in croplands lawns and gardens, along roads and railroads, in orchards, and in ponds, lakes, and irrigation ditches. Some herbicides are non-selective and prevent all vegetation from growing. Other herbicides, more frequently, are developed to selectively remove certain weeds from certain crops with no adverse impact on the crop themselves. Unchecked, weeds quickly overtake crops, as this slide shows, robbing them of moisture, fertilizer, and sunlight. Cotton on the right, you see, is a quite dwarf plant developed through many years of breeding, and on the left, the pigweed and other weeds have completely overtaken the cotton. Yields are severely reduced, and the presence of weed seeds in the harvested crop can reduce its market value. Well, how are herbicides, insecticides, and fungicides discovered? Well, it takes about 8 to 10 years and almost $50 million to discover and bring a new product to market. Yet remarkable advances have been made in recent years in the discovery of new pesticides. Early products that blocked relatively nonspecific processes required high dosages to be effective, often many pounds per acre. But today, numerous products are available and others are in the pipeline of development with dosages or use rates of merely a teaspoon to a tablespoon per acre, and much more environmentally compatible. They break down quickly and are safe to man and the environment. For many years, it was known that pesticides applied to the surface of the soil were either bound to the top inches of the soil or quickly broken down by soil microorganisms. People did not believe that they would survive the passage through the soil and contaminate our groundwater. But with the development of new, extremely sophisticated detection equipment, this conclusion was proven false. Previously undetected traces of pesticides were found in our drinking water in a number of locations. These detections in several states, as you might expect, caused public concern, because at that time no one knew which levels would pose an adverse health risk. The prospect of widespread water contamination quickly took this from the arena of scientific study and made it front-page emotional issue. Public interest groups called for immediate legislative and regulatory responses. And on primetime television, farmers and other users of pesticides were portrayed as a source of the problem, no longer stewards of the land. As you might expect, the reputation of the pesticide industry dropped even lower. But is the public concern fully warranted? Do the minute traces of pesticides found in some well water pose an adverse health risk? Or are they such a very low level that they have no biological activity at all? The answer to this requires an examination of just what risk is. Risk is a combination of hazard and exposure. Hazard can be the inherent toxicology or toxicity of a product. The exposure, the relative concentration and the duration and time to which you're exposed. Risk is a combination of both hazard and exposure, and without sufficient exposure, a very hazardous product, a very hazardous chemical, does not pose a risk. For example, chlorination and fluorination of drinking water have profound social significance, although both products are quite poisonous at higher concentrations. And furthermore, life-saving drugs are only life-saving if taken at the proper dosages. Before any pesticide can be approved for market, it must undergo extensive trials, very similar to the testing of new drug candidates. They must pass a battery of at least 40 different toxicological trials, often taking several years and costing many millions of dollars. Volumes of toxicological data are required to approve a new pesticide. As shown in this photograph, the stack of data beside this woman represents about 6 years of tox testing on a new herbicide developed 5 years ago. In addition, numerous studies determine the chemical's environmental fate, efficacy, and soil persistence. From time to time, the EPA changes their test requirements and then asks for additional data on older products. At that point, additional studies must be done and the data submitted to the EPA in order for the registration to be maintained. These tests in total must demonstrate to the EPA that the product in question can be used safely in the marketplace. Only then will a registration be granted. This information is printed on the pesticide package in an accompanying brochures and often includes messages regarding wearing of safety equipment, goggles, gloves, and other things, and how the product can be used and where it should not be used. All this testing data is also used by the EPA to develop guidelines for interpreting safe levels of pesticide exposure, that is, residues in our food and our water. Focusing again on water, these safe lifetime exposure levels developed from the toxicological studies are called health advisories. These are not enforceable standards, but these are health guidance levels developed recently by the EPA to help us interpret the data. They give us a health-based information base to make judgments about the significance of detections of minute quantities of a chemical in water that we drink. They are expressed in parts per billion, and several examples are shown on this slide. Many of you have probably heard or read much about the contamination of groundwater in recent years. Many activities of man and nature contribute to this. For example, as this slide shows, the U.S. Geological Survey published a report in 1988 stating that about 2% of the nation's groundwater is contaminated. Agricultural pesticides are a minor but widely recognized contributor to this contamination. Results of several recent studies conducted of U.S. wells are giving us an accurate picture of the extent of pesticide contamination at this point in time. The EPA is about 50% completed with a nationwide study that will permit extrapolation to most wells in the United States. To date, the water quality looks very good, but further tests must be completed. At present, few detections, and most of these are well below the lifetime safe exposure levels called health advisories. Similarly, Monsanto just completed a nationwide study of wells. Although the results are not fully digested and haven't been published at this point, their data confirm the early results of the EPA study. Only about 2/10 of all wells had levels greater than a part per billion, and only 2 wells of the study completed had detections greater than the U.S. EPA health advisories. A large-scale California study found similar results. Few wells with detectable pesticide levels and very few with levels above the health advisory guidance levels. Similarly, a university-conducted study in Ohio suggested that most wells in that state were not contaminated. These don't represent all the wells in the country, and certainly there are some parts of the country where agricultural chemicals are applied in large quantities. Agriculture is a main industry, and because of local geological conditions such as sandy soils and shallow groundwater, they represent a hazard, and vulnerability is greater than in other parts of the country. These new studies suggest that the actual degree of groundwater contamination, however, in the country as a whole, is not as bad as one would have been led to believe earlier in time. Yes, there are some combination of circumstances where pesticide uses have and will continue to contribute contamination to groundwater unless care is taken to use pesticides properly. But water quality protection programs will also require the education focused on pesticide users to give them an understanding of how best to store, mix, apply, and dispose of pesticides in their containers, how to properly calibrate their equipment, how to protect their wells, how to prevent and clean up spills, etc. This is what the Alliance for Clean Rural Environment, called ACRE, does, of which I'm a part. It's a program to encourage the safe and responsible use of agricultural crop protection chemicals so as to protect our drinking water and our environment. It's a nonprofit, nonpartisan education and information effort sponsored by the makers of U.S. crop protection chemicals. In conclusion, pesticides are important tools for farmers, horticulturists, turf managers, foresters, and many other agricultural professionals. If used properly and with attention to potential soil and water vulnerabilities, they can continue to help us retain our title as the breadbasket of the world. Improper use, however, will lead to environmental degradation, more public concern, stricter laws and regulations, and jeopardize the food, feed, and fiber production capabilities of this country.
Yes, I'd like to ask a question about the casual use of pesticides by ordinary people. I gather that many of them are neurotoxins specifically, and I wonder if you would address the neurotoxicity of many pesticides in common use.
Pesticides vary in their acute toxicity from products that are safer than table salt on an acute point of view to some that are extremely toxic, as you suggested. Products that are extremely toxic are generally restricted use products, products that are not available to the homeowner, products that are not available to people that have not passed certification to use them. Some products are available on the marketplace which require considerable amount of care when using them. We learn more about the use of these products all the time. Certainly, reading and following the label instructions on the containers when we buy them, either at our farm store, at our grocery store, if they are for foliage plants at home, will help us avoid some of the hazards associated with some of the more toxic products. But in answer to your question, the more extremely toxic chemicals are generally not available for the casual user. They are products that are used only in the supervision and control of certified pesticide applicators.
Since government regulation of herbicides and pesticides began, have any deaths, human deaths, or serious illnesses been directly attributed to involuntary consumption of the chemicals, that is, through groundwater contamination or maybe on fruits and vegetables in the grocery store or something like that?
This will be addressed by another speaker on the panel later. To the best of my knowledge, there haven't been any scientific data that human deaths have occurred as a result of direct ingestion of food and water in a normal diet situation. I do believe there have been a number of deaths due to involuntary exposure, such as spills or people who were trapped in a train car. You might have read the news recently. Here's a situation where they were unaware of the presence of the pesticide, and the pesticide was used probably in a legal manner, but they were not legal in their presence in the car. But as I said, this subject will be addressed much more expertly by a subsequent speaker.
As you can tell from the last few speakers, the scientific and regulatory task that faces our government and indeed society as a whole in regulating pesticides is going to tie up a lot of scientists' manuals over the next 9 years. And it does appear to be emerging as one of the most controversial and perhaps costly of the environmental challenges that we face in this country and indeed around the world. What I'd like to talk about and suggest is that there's another set of factors that govern the farmer's choice of technologies to control pests and indeed the types of pesticides that are used in the ways that they are used. History suggests, including a review of the case of DDT, that biological problems with the effectiveness of DDT and other chlorinated hydrocarbons that arose from the emergence of resistance in insect populations had really led farmers to abandon the chemical because it was just working less and less well and costing the farmer more and more. And as a result, the farmer really, before the regulators got around to canceling the product, most farmers had abandoned it and moved on to a new family of pesticides that are still in wide use today. What I'm going to talk to you about is some of the new opportunities that farmers are pursuing across the country to change the mix of technologies and strategies that they use in controlling pests. Chemicals are only one way to control pests. There are a number of other ways. And I think the only really hopeful sign for our country and indeed around the world is that new science and some new understanding of the ecological interactions in a cropping system suggests that we're going to be able to do a much better job in the future of keeping pest problems to a minimum so that our reliance on pesticides is lessened, and when we do have to use them, the chance that there's going to be some risk to wildlife, to applicators, to the public will be lessened. I'd like to start with some slides that are based on a major report that we released from the National Academy of Science in September of this year entitled Alternative Agriculture. All the tables and information and conclusions that I'm going to share with you today about the economics of pesticide use are drawn from that report. Our report talks about a concept, alternative agriculture. Alternative agriculture it really is a different approach to managing a farming system that doesn't rely so heavily on just purchased inputs or just pesticides or just tillage or any one practice, but looks to opportunities in a more holistic sense to manage the cropping system. These systems tend to rely more heavily on the biological interactions that are possible and the genetic potential in the crops, including the genetic resistance in crops to pests. And it also relates to the the decisions a farmer makes about what crop is going to be grown on what land. Because after all, one of the ways to avoid a pest problem in a particular crop is to grow a different crop in that area until nature works its course and the population levels of that pest are reduced. The opportunities to pursue alternative production systems are emerging all across the country, and were in fact spurred along considerably by the economic crisis that farmers faced in the 1980s. Farmers across the country, as their crop prices fell, were forced to adopt a number of practices that would reduce their production costs. Crop rotations have emerged as an old practice that is finding new application with major benefits in terms of the controlling pests naturally, in increasing the efficiency of the nitrogen cycle, which is one of the major plant nutrients, and in improving the overall economic performance of the farming system. One of the key alternative practices that's highlighted in our report in great detail is a concept called integrated pest management, or IPM. IPM holds great promise to bring about a reduction in pest pressure of all types so that farmers can be less reliant on pesticides. And again, some of the standard IPM practices involve crop rotation, weather monitoring, the use of genetically resistant cultivars, the timing of planting so that pest populations don't get a chance to build up, and the introduction of various predators and other biological control agents into the cropping system. Some additional examples of alternative cropping systems involve different ways to control weeds using mechanical cultivation, and there are many opportunities to reduce the reliance on herbicides as well through banding the herbicide in the row and using mechanical cultivation between the row. There are also a number of alternative practices that are used to help improve the conservation of soil and water. In animal agriculture, there's also the need for the use of pesticides to help control external parasites as well as keep animals healthy. And our report contains a number of examples in that area, which I won't dwell on anymore today. This table shows the trends in the overall use of pesticides, and it's quite apparent that increased use of herbicides constitutes one of the majority of the growth in pesticides. Most herbicides are applied before a crop is even planted, and rarely result in food levels of residues in food that pose any risk to people, to consumers. The major problems and concerns with herbicides relate to their potential to leach into groundwater and some of their impacts on wildlife. Certain crops are more reliant on pesticides than others. Corn is by far the most chemical intensive of our crops grown today, although some of our fruit and vegetable crops, particularly grown in certain parts of the region, certain regions of the country, are heavily reliant on pesticides, often in particular fungicides for plant disease control. Pesticides form a major cost of the variable production costs faced by farmers. Up to 30 to 40% of the variable production costs for certain crops are accounted for by pesticides and fertilizers, and therefore the skill and ability a farmer brings to the management of these inputs has a major impact on their economic performance. Again, in certain parts of the country and certain crops, these inputs account for as much as 30% of the variable costs and 15% of the total costs. It can become very confusing in comparing production costs for certain inputs or for certain crops, and one has to be careful in defining one's terms. This slide indicates that on the basis of cost per acre, The regional costs of producing corn in the Corn Belt and Great Lakes states in the Southwest is fairly nearly the same, as well as the portion of the costs accounted for by pesticides and fertilizers. But when one looks at the costs on a per bushel basis, it becomes evident that the costs are much lower in the Corn Belt states, largely as a result of the higher yield levels. And this slide and a series of findings in our report that relate to regional differences in production costs, disease pressures, and reliance on pesticides suggest that there's some opportunities for the country in bringing about a better match of cropping patterns and pesticide use. Obviously, one of the problems and concerns, particularly with herbicide use, is contamination of surface and groundwaters. This slide is derived from data on treated public drinking water supplies from surface water sources in Iowa, and it shows that there are levels frequently found, particularly in the spring, of a number of the widely used herbicides that don't generally exceed the EPA health advisory levels, but sometimes do. And this remains a growing concern both at the state and federal level. So one way to deal with the challenge posed by pesticide use is to develop more effective IPM systems. Our report documents several instances where some new technologies have made possible integrated pest management systems that even increase yield levels or at least hold them at the same level, increase the return per acre, allow the farmer to bring about better control with less of a total volume of pesticides, although often IPM systems will require more applications of more narrow spectrum products. Economic benefits of IPM can be very substantial, ranging up into the hundreds of millions of dollars for a given crop, even in one state. Texas cotton producers would be unable to continue to produce cotton without IPM because of the emergence of genetic resistance. Another important crop is apples. IPM systems have been developed and are being developed in apples and are going to make a big difference in helping apple producers produce those big plump red apples that we've grown accustomed to without such heavy reliance on pesticides. There's great concern about pesticide use in apples because children drink so much apple juice and often eat a lot of apple products. So it's a very significant challenge to try to develop improved IPM systems for apples. There are many examples of individual practices that could be noted. They range from special pheromone traps, as shown here in Florida, where a entomologist is carefully monitoring the insect levels to determine the appropriate timing for pesticide applications, to the staking of ground to keep the sunlight away from the soil surface so that weed seeds won't germinate, to a special tillage practices that are evolving in the Midwest. This is a ridge till system showing the cultivation equipment that's used in between the rows to control weeds. This is a very important new tillage tool used in much of the Midwest called a rotary hoe, which brings about a high degree of weed control early in the season. Again, the economic benefits of IPM are really quite considerable, and the use of IPM on certain crops has become quite extensive. For example, over 80% of tomatoes grown in the country involve an IPM system. Government policy, as documented in our report, has a substantial impact on pesticide use by virtue of a number of economic incentives embedded in a variety of programs that are going to be reviewed in the next Farm Bill cycle. Regulatory policy also has a major impact on the choices that producers make in controlling pesticides. Federal grading standards that establish certain cosmetic standards for produce are very important. There's no doubt that pesticides confer major benefits across society in bringing about a higher level of agriculture production. And there's really two myths that we have to watch out for. One myth is that American agriculture can quickly abandon all use of pesticides without any major adverse impacts. This is simply not true. It's going to take many, many years to make a transition to more biologically based production systems. A second myth that's equally dangerous is that all pesticides work well all the time and that they're always a real bargain for society. This is simply not true. The reason that farmers are developing innovative pest management systems and going to more biological controls is because chemical pesticides are not working well in several instances, and their cost is becoming too high. The challenge for society is to diversify the strategies that we use to control pests. And we have to do this as a necessary step in bringing about and lessening the pressure on our existing pesticides, particularly those that are most hazardous. So I think before regulation is going to solve the problem of food safety, we're going to bring about many changes in how we use these products. The choice for society is whether new policies and programs and laws are needed to accelerate the rate of this change in the technologies that we choose to control pests. Thank you.
But finally, the question for EPA is, can you trust us? How do you really feel we are doing our job? My feeling is that EPA is in fact dedicated to good science and to the highest energy that we can muster to manage pesticide use wisely in the United States. I think you can trust us, but I also recommend that you don't trust us too much. The public has the right to ask questions and has to get answers from EPA. Is this pesticide necessary? Is it effective? Is it persistent? What are the risks, both direct and indirect? And what are the alternatives? And is EPA properly balancing that risk-benefit equation? You need to help us by asking these questions and many others, and by, most importantly, expressing your policy preferences. Public policy is a complex web of competing interests. EPA is simply one major player on the field. We have the pesticide manufacturers, the users, and the consumers, among others. Everyone has a necessary role in this decision-making process. It is a system of checks and balances. It forces a decision. In the face of uncertainty, decisions must be made. We must get on with life, but we may turn out to be wrong, and we all have to understand that we may be wrong and accept those risks in those decisions. The next decade, I think, will be extremely exciting. We're going to review all these current pesticides. Let's take up the challenge, take our best shots, recognize uncertainty, accept some risk, and go on with the job.
And I wonder if you could comment on the ethical issue of the manufacture and marketing of pesticides in third world countries which have been banned in this country.
I'll start the comment. Undoubtedly, there are ethical issues that have to be considered and are considered when products that are banned in the United States are shipped to other countries, whether they be third world countries or countries that are just farming in a different way. The consideration has to be one of both benefits and risks, though, because we're here in the United States. We have an excellent standard of living. We have an awful lot of time and money to consider removal of extremely small risks in our society. I mean, we're discussing airbags versus seatbelts and things like that in cars. You get into other countries where they're just trying to survive, and the mortality rate of infants is many, many, many times higher than in the United States. They're faced with plagues of locusts and other insects. They're plagued with diseases because of tropical and subtropical climates that we don't face in many cases. They're also faced with unsophisticated farming methods. They don't have the equipment and the technology that we have for either growing, harvesting, or storage of crops. And under those circumstances, they're looking for answers. They're looking for survival. And in some cases, the only products that will work, the only products that will kill the insects, prevent the diseases, and stop the weeds from taking over the crops, perhaps are products that either are presently banned in the United States because a new product is out that is safer, breaks down faster, or used at a lower use rate, or perhaps products that have been replaced with higher technology in the United States, but yet are still available in other countries because they are so inexpensive and the regulations haven't been established. There's no excuse for not looking at the health and safety aspects of it, but where there's a demand for the products in foreign countries, those products will generally be sold. I defer to other people too.
John, I completely agree with everything you said. I'd just add a little bit to it, which is that first of all, any simple profligate dumping of American products on those other folks, of course, is an unethical and immoral thing and shouldn't happen. I don't think that much happens, although that's something I've never looked into myself. I generally understand that very little of that really happens. Second, when other countries are on the market or come to United States AID or other agencies asking for assistance in this area, decisions made ought to be very judicious in weighing risks, benefits, and costs, and trying to minimize the risks, both to that local exposed population and the global population in the long run. So again, be smart about which pesticides are applied. But I must say that John's right. People's equations are very, very different, and many countries have enormous problems that we are just fortunate not to have to face. And I think it's just as wrong to deny people benefits of some kinds of pest control agents. I don't want to defend all pesticides, but to simply say they don't have right of self-determination seems to me very wrong in an international world. I also don't think that third world leaders and scientists are stupid. And I see a lot of evidence that they're trying to become much better at making these decisions, screening their choices, and making commitments that make sense for them.
Here's another aspect of this that I'd just like to comment on quickly, which is that there, in one sense, in this very complex equation, we can see pesticides used in other countries which then come back into this country in terms of imports. And a lot of hue and cry has been raised recently regarding the question of the quality assurance, making sure that the residues on the imports are at least as low as the residues that we impose upon our own growers. That's a competitive thing, and I think can be fixed relatively easily through improvements in our import monitoring programs. But in that same chain of taking in crops from other countries, which then compete locally, there's an interesting ethical question in terms of the restrictions we place on our own growers versus the restrictions on the growers and pesticide users in other countries. And if we allow the crops to be treated with pesticides which are severely restricted and banned in the United States, allow those crops to come into the United States, aren't we then in effect ethically exporting the risk to the local users in order for us to gain the benefit of importing the crops? I think this is a significant ethical question that has not been dealt with adequately.
One of the results of high pesticide use is the ability to grow near perfect fruit. She wants to know if anyone on the panel thinks consumer acceptance of less perfect fruit will actually result in less pesticide use. Any prognosticators here?
Well, excuse me. First of all, I think that one of the hopeful developments that's addressed in considerable length in our report is that consumers probably aren't going to be faced with a choice between pesticide-laden fruit and fruit that's full of wormholes. Some of the most attractive produce that consumers encounter today has no pesticide residues on it and has in fact been grown with a IPM or organic system that results in no residues and no damage. So I think that there are those that claim that stricter pesticide regulation is going to result in a substantial change in the cosmetic appeal and quality of the fresh fruit and vegetables that are available to the consumer. And there's no scientific evidence or basis to predict that being true. In fact, there's been tremendous progress in just the last decade in producing fresh fruits and vegetables in major production areas with sophisticated biological systems that rely somewhat on pesticides, particularly when an unusual weather pattern might evolve or where an imported pest is brought in. I mean, at this very moment as we speak, Los Angeles is being sprayed once again with malathion to control the medfly. The reason they're doing that is they don't want that pest to get established in the southern part of California's agricultural industry, because if that pest becomes established, the pesticide applications that will be required will disrupt the biocontrol and IPM systems that have been developed at great expense, both to the growers and the citizens of the state of California through their land-grant universities. So I think that people should be very skeptical about those who contend that a stark choice is going to have to be made here between cosmetically perfect fruit and damaged fruit, because I think that there's no reason for that to occur, and indeed I don't think it will.
One further reflection on that as well. You have to keep in mind that pesticides are used in the production of fruits and vegetables across this country, and you look at the data on market basket surveys of actual residues on the fruit and on the vegetables in the stores, and they are very low or non-existent under current production schemes. Now, certainly biologicals and IPM and other things are very important and have a place in the future production of agricultural products that we use in our diet. But we have to keep in mind as well that the current food supply is very safe. The residues are either non-existent or low enough to be within tolerance at least 95 to 98% of the time, based upon the statistics that I've seen. And when I go to the grocery store and I'm looking at this food that has been treated during its growth cycle with pesticides, but I do know, based upon the statistics that I've seen, that it's probably does have no residue on it, I see the homemaker, and I do it myself, picking through hundreds of green beans, hundreds of strawberries, tens of tomatoes, looking for the one perfect one. Now, if that's the case under current situation, what's it going to be when we cut back by a half or three-quarters under IPM or other production schemes, the amount of pesticides that we use?